This is a handheld spot welder that I have that was built in 1997. It originally came with these big electrode arms, a hand manual trigger, and is made to run off of a 120 volt outlet. I modified all three of those things to allow for being able to get into tight spaces with these little electrodes here, and voltage control through this VARIAC, so you can control the amount of power being delivered through the weld. And most importantly, I added an outside circuit to be able to finally control the pulse timing of the weld. Yep, you see that was too much. This is a rough diagram of how this spot welder works. It's just a standard AC spot welder where there's a transformer inside that steps the voltage that you put in way down and ups the amperage. And the way it does that is the primary coil of the transformer has a lot of windings, and the secondary coil has very few windings. And so you feed it in, normally if you just plug it straight into the wall, you feed it in 120 volts AC, roughly, let's say 14, maybe 15 amps, and you get out, depending on the setup of the electrodes and whatnot, and the conductivity of your material that you're welding, anywhere around 4,500 amps at like half a volt. So you get very high amperage. And using that very high amperage, you're taking advantage of something called resistive heating, which normally in electronics is very bad, and that's how you fry components and stuff like that, because the resistive heating ends up upping your temperature, and eventually you burn out a MOSFET or a switch or whatever it is. And so you try and minimize that as much as you can, but you are taking advantage of resistive heating with this system. The resistive heating formula gives you, power in watts is equal to amperage squared times the resistance of the material through which the current is being passed. And so if you can up your current that you're passing through the material, your power goes up with the square of the current. And so you can dump a bunch of wattage through a material if you have a very high current passing through it, and it leads to immense heating, and eventually the material melts, and so you get your weld. And this is just a really easy way to weld a material. It has downsides to it because you need something that isn't too conductive, because if you don't have this good resistance, you're not going to, if you don't have a high enough resistance, you're not going to dump enough wattage, and so you can't really get the material to melt together well. With stuff like copper and aluminum is notoriously hard to spot weld, if not impossible. Usually if you're going to spot weld aluminum, you need a resistive layer of something like, let's say, nickel in between that will actually facilitate this resistive heating, because otherwise you just blow holes through the material essentially, or you overload your spot welder. And you also have DC spot welding, where you charge up a capacitor and then you discharge that capacitor through the material that you're spot welding. Those are kind of fancier systems that have better control and whatnot, but this handheld spot welder that I have is just simple AC, uses transformer to get the high current out, and that's it. And if you want more control, you can control this input voltage with a VARIAC to give you finer control of the power that you're putting through, lets you do thinner materials like I was saying. And another great upgrade would be, controlling the time that you are holding this weld and allowing power and current to pass through the material. Because right now, the way that these are made, or that mine is made at least, you just have a figure trigger, and so it's hard to kind of get a really fine timing. So I might play around with that in the future and actually see if I can control that trigger with like a high power relay or something to really give myself much better control. This is my Miller handheld spot welder that I am going to be modifying. It has 2 electrodes that come down and clamp around whatever workpiece it is that you're trying to spot weld, and it passes really high current through that workpiece until it melts. Here's the trigger, which is used to switch power to the primary part of the transformer, which sits inside the body right here. And some limitations that this has is that the electrodes that come on the system, that come standard with the system, are very bulky, and that makes it hard to work on small, intricate pieces. And the voltage, so the power going through the electrodes isn't really adjustable. You plug it into the outlet and you get the outlet voltage. And the trigger timing is really tough to get right because you're just controlling it by hand. And so if you're working on a very fine piece of metal, something thin, there's very, very little margin for error. The way I set up these custom electrodes is kind of interesting. It allows you to get into really kind of tight geometries to make welds. So something like this cylinder would be one example where you can get that in there, because it's really limited by the height of this top electrode, which is just under 1 centimeter. So you can really get into tight spaces with this, which was kind of the point of this for me personally, is to be able to make fine welds on like ring structures and things like that. Here would be one example. This is really messy. I was just messing around, but something like this you can't really do with these big arms because it'll just get in the way. And they do sell specialized tips and whatnot, but those are super expensive, and from what I've seen, they're still way too big. And this works quite well. These don't really get all that hot. There's enough contact here for good conductivity without me even really trying all that hard. I just use these hose clamps. I also use this VARIAC for controlling the input voltage to the spot welder, because normally you would plug the spot welder straight into your standard 120 outlet, and that really limits your power delivery options because you're basically operating at full blast no matter what, and so you can really only have control by how long you keep the weld going. And with certain thinner materials or higher resistance materials, you're probably going to run into issues of where you can't really hit that trigger fast enough and let go fast enough before you just blow right through the material. So that's where this VARIAC comes in. It allows you to limit the power and heat that you're dumping into the workpiece. And in my opinion, the best upgrade to this spot welder is this automatic timing control. So how long does it deliver power? It hijacks the circuit that is switching the electricity coming to the primary of the transformer in here, which is controlled with this trigger here normally. And so what I did was I wired these two lines in parallel with this already existing triggering circuit. This is what it looks like from the inside. And so now these two wires, this is the live side, and then the one I have marked with the white band is the neutral. Now it can be switched by either this manual trigger or this solid state relay, which is rated for 40 amps up to 480 volts AC. And especially since I'm operating this in such short bursts, this is hugely overkill, which is good. A lot of safety margin on this. And the relay itself, on and off, is controlled by this Arduino, which is in this little box. I have an LCD display screen and an encoder button here for control. As far as the control options go, the main cycle control, these cycles are 16.67-ish milliseconds. The reason being is that this is made to operate at 60 hertz line frequency, and this relay cross only turns on and off at the 0-point crossing point of the waveform. And so it's best to make the timing in such a way that accounts for this, because otherwise you're gonna be missing half cycles here and there, and it won't be as precise timing wise. But yeah, so this allows you to pick however many cycles you want it to stay on for. There's a optional warm-up mode which will do a pulse before your main welding pulse to warm the material, break through the oxide, get a more consistent contact. And then after the warm-up you have a pause time, after which you will move to your actual main weld cycle after the pause. And after that there's a cool down time that can be modified that will basically not allow you to do any more welds until that's up. And then I just long press while on the hold to weld menu item. So if I long press for 1.5 seconds, the weld will go. And actually it's hard to see because right now the time is so short, but so 60 cycles will be 1 second. And so what we'll see here is this little light will come on for 1 second. Yeah, that's the pulse timing control part of this. And so with all three of these modifications, it's really made this thing way more robust, way more capable, way more precise. Specifically this part right here, the pulse timing, gets you really, really good repeatability, which I like, because normally these are used for like spot welding sheet metal, big bulky items where you have a lot of margin in terms of how long you pulse it for, and you'll still get a decent enough weld. The stuff that I'm working with, thin wires, thin foils, I really have no margin at all. If I go too long, I just blow right through the material. If I don't go long enough, it doesn't weld it. So yeah, this is works like a charm. I would recommend this to anyone that's looking to upgrade their handheld spot welder. I know this is a very old model. It's built extremely well, so even though it's from 1997, almost 30 years old, it's still in fantastic shape, works perfectly. But they sell these, I think, from like Harbor Freight nowadays for a lot cheaper, and essentially the way that these are made is the function is exactly the same, where you just have a transformer in here and you're switching the live on and off to the transformer primary, and the secondary gets you the very high current, low voltage for the welding. So, you know, if you have one of these from like Harbor Freight or something, you could do something very similar very easily. The architecture would be the same. Okay, let's use the fully modified system here to establish a good parameter set for this stainless steel foil that's roughly 50 micron thick. So I've got all these little coupons laid out. So first thing that we will do is we will go ahead and turn up to kind of full power, no control, and we'll use the trigger to try and make one of these welds with the stainless steel foil, just to see if it's even possible. Okay. Oh, looks like that. Yeah, it's too much. So it basically blew right through the foil, and then it melted to the electrode as well, which is a problem, because when you pull it off, pulling the foil off cause tearing. What we will do is we'll use the control system. First, adjust the VARIAC. Let's try maybe 70 volts. Here we go. Okay. That's still getting stuck. Okay, so that actually kind of worked fairly well here. I'm gonna pull this apart. And yeah, fully welded. Pulling it apart basically tore at the weld, or tore around the weld, not through the weld. So it's good fusion there of the metal. But we are still kind of melting to the electrode, which isn't good. I'm just cleaning this up a little bit, because that melt gets on there and then it'll mess with the contact. So 70 volts seemed like it was still too high, and I'm gonna actually use the pulse control as well to see how good a repeatability we can get, and if we can really nail down a good spot where you get good fusion but it doesn't melt to the electrode, and it's just sort of a sweet spot for welding this material. So we're at 70 volts and I've got 30 cycles selected, which translates to a ½ second pulse time. Okay, I bet that's too long. Oh, maybe not. Let's see here. Yeah, it's still getting a little bit stuck to that bottom electrode. So the weld itself is pretty good. Yeah, it's kind of hard to see, but basically there's a little hole in the foil now where the weld was, so it failed around the foil rather than at the weld. Okay. Still getting stuck to that bottom electrode. I want to get this to a point where it's not getting stuck to the electrode anymore. So I think a 1/4 second is a good spot to be. I'm going to turn the voltage down now to 60. Let's see how that does. Okay. Oh, okay. Almost didn't get stuck. See how this did. Yep, that's still a good weld. Okay. So that might be about the sweet spot. So with these mods, you know, it's not quite industrial level precision spot welding, but it's way better than this thing was, and it's actually quite precise now. So very versatile. I would recommend anyone that's trying to do some kind of more unique spot welding for their hobbies to try this out, and let me know if you want any help with setting something like this up, or the Arduino code, anything like that.